for the DSP operation example, I think, yeah, that would be mini signal correlation, digital filtering. So the one that might happen always in our subject would be this one, filtering. Modulation, demodulation. Okay, this one is vice versa process. Transmission. So okay, this is okay. And this one, DSP operation filtering, by far the most commonly used DSP. So this one is the one that I mentioned. I think this is the fourth time about. So yeah, filtering is to use the focus that parts of the spectrum interest only, rather than and whereby the rest will be deleted. I mean filter. So speaking of the filter, we have several types of filter in our hand. So I guess in the analog world, you guys have already expert about this in several subject before. We have heard about the low pass, high pass, band stop, etc. Notch filter, and yes. So low pass meaning they are passing only the low, okay? So meaning remove the high. So yeah, it's happened goes to the second one too. High pass meaning remove the low. Okay. So band pass and band stop, it's actually, so yeah. And yeah, I think that would be no problem. So this is an example of happen when we have the clean clean voices. Like I'm not sure about what is the text has been pronounced by one person. Was it Aini or something? I'm not sure. So this one is given that the noise like baby crying or like people is working by the drilling the wall is having a noise or something. So then say that we have this is the time. So happen is the frequency domain. So this is actually different between these two. So this one is T. This one is normally in T, and this one is normally in F frequency. So that's the reason why, if we take a look at the mini subject regarded to the signal system, discrete signal system, image processing, and so on and so forth. So the core thing is actually converting the times domain in the frequency domain for seeing the things that cannot be seen in time. So example, so this one is obviously noisy, right, compared to this. So it clearly can be seen by the frequency, whereby at the time, sometimes it's difficult, but it's not a majority cases, but in some cases. So the application that we have are communications, modulation, signal security, encrypt and decrypt, compression. So the data compression, so communication, I guess many of you doing the telecommunication, right? Signal security is actually like we tampering. Okay. So yeah, speaking of tampering, iris something. What else? Face recognition lately, and etc. So yeah, this one. Okay, I just want to give you one view of kenapa dia susah. Example, you have phone, right? This one is iPhone 12 Pro Max. Example, okay. So this phone created by a company known as this, okay. So let's say this is a face recognition, right? So you pull out your face over here. Okay, so the moment that you register your face over here, so okay, the things wording of the security is important because happen when a company either this or this, what else, or this or this. Speaking of the security, I'm not sure about the 100% secure. The face recognition and thumbprint by was the information that we give to them is 100% secure or only 98% secure. So that would be debatable. So because people tend to bias on, okay, I like Apple, I like Samsung, I like Xiaomi, and so on. So that will be biased thing. So that the core thing is actually what we have in our hands. Is it the password and the biometrical identity of us is secure by this company or not? So that would be the idea. Data compression is, I think, if you guys know about JPEG 2000, so that would be, I think, 1999, and goes to the JPEG and JPG and what you call it now is I mean, so you can see the evolution of the data. So meaning from starting point of JPEG 2000, because I did my master for using the JPEG 2000. It's not JPEG because yeah, I'm an old man right now. So I think you guys don't know about the JPEG 2000, right? The first introduced by the JPEG. This one is a group, joint professional expert group. I'm not the long term. Then, so lately, we have this and this are frequently known use for the layman right now. So we don't know about the normal the previous one. So lately, this is raw. It's slightly important right now. So raw, it's not a compression yet. So because once you have raw file, raw is actually, if you remember about the Kodak time. Kodak is actually, Kodak film, film Kodak, it's actually a raw file recently. So that's the reason why those company right now, Apple, Samsung, Xiaomi, Realme, having the professional setting in the camera, claiming that they have a raw file for each image. So because the raw is actually the untouched pixel captured by the sensors that we have. Example, you have a tree camera. Okay, that would be the compression. So let me how they deal with it. From the raw is the biggest one, and will be converted to the JPEG and PNG and so on and so forth. Signal denoising, filter denoise reduction. Okay. Audio processing, I think that would be fine. Image processing, yes. Okay. Data analysis, feature extraction, which this one is actually being discussed frequent in this field. Feature extraction, as the feature is slightly is the most important things rather than processing lately. Whereby example that we want to track the people's smile or sad or no feeling, just boring and so on. So that would be called a feature in image processing. Frequency, spectral analysis. This one is a different meters, spectral analysis. Okay. Other application, image processing. Okay, this one, like if I talk with image processing, I go on telecommunication. Echo, everyone knows about that. Adaptive equalization regarding to the sounds. Video conferencing, Zoom and so on and so forth. Data communication, yeah, that one. This one is, yeah, the currently became well-known subfield, biomedical. So I think EEG and ECG, Afifa is around, and Rawiani, and
Yes.
okay. Consumer appliance. This one is, yeah, related to us, PlayStation 5. So those who are tend to gaming all day long. Cellular phone, so the iPhone 12 Pro is just launched, and digital camera who tend to be the mirrorless right now. And I think CD and VCD, this one is an old. DVD is okay right now. So that would be the idea. Advantages of DSP are guaranteed accuracy, obviously, no off-bit use, perfect reproducibility. So meaning we tend to track the information of the bits, no drift information as performance as a signal, analog signal, because somehow we have a glitch here and by. A greater reliability, smaller size. This is obviously small because you can take a look at JPEG file versus RAW. So I think some of the boys know about this, maybe the girls too, who are very keen about the photography. So I think that would be this point. Lower power consumption, obviously, if we have the small data, let's say the JPEG nowadays 0.5 meg. This one is slightly 8 mega. So just imagine how many times. So rather than your phone has 64 gigabyte RAM, 6 gigabyte storage, so that would be the constraints over there. A greater flexibility can be programmed. This one is lately, yeah, you have apps right now. You can, this one is very good. Apps, not your current face and your old face. That would be, yeah. Superior performance can perform functions that are possible with analog digital adaptive. And yes, okay. So disadvantage is actually complexity. Obviously, we need to design. The circuit is very headache at times to pull the, let's say, C++ and Python and so on. Speed and cost can be expensive, obviously. 10 years back, but I'm not sure about now. But yeah, it's affordable right now. But this statement will be available 5-10 years back, but we still use because this is the theoretical session. Design time due to the shortage, okay, that would be required the special engineer to design. Okay, for the summary, okay, so the thing is, you should know what is the signal processing, digital signal processing is all about, and the basic element in the system. So like I said in the first slide before, so we have signal, system, and DSP, right? The three elements. So what is the signal is all about, what is the system is all about, and what is the processing is all about. So what is the reason why? And as a student, you should capable to explain what is the reason why digital signal processing is preferred rather than analog, and the requirement of ADC and DAC. So yeah, that's all for the lecture for today. But before I end up the lecture, basically there are several things to be understands too about the DSP basic maths over here. So we have meaning pre-understood knowledge when you deal with DSP. Likewise, you need to know about the basic mathematics in your mind. So let's say trigonometry, complex number, complex exponential, factorization, long division, irrational functions, sum product, and so on and so forth. So trigo is actually a demand because they are using in the phase frequency domain. Complex number also too. Factorization is actually when designing the filter design. And then sum product would be if we have the long way of a signal, we need to cut the noise signal. So that would be the idea of having the basic requirement of maths in our mind before we start our journey to the second chapter and so on and so forth. Okay, so these are the trigo. If you can take a look at your home. So this is cost. I think this is normal, but be careful of this. If you choose to not understand this cost, when say cost 0 is 1, so it's non. So complex number, we have this. Be careful about this square root 2, 3, pi, and so on, about the J complex number. So because we have the real and image imaginary plane in Z transform. So this way, we will deal with the with what they call it, the stability of the design. Let's say we have poles here and here, so we may say that this is stable and so on and so forth. Okay, not stable or stable. So that would be the idea. So this is needed to be in our mind beforehand. Okay, this one is imaginary plane. So you need to know what is the meaning of this, and AJB. So the A is actually for the x-axis and B for the imaginary plane. So this is polar coordinates and so on. So this Euler is actually cos theta plus j plus theta, and this is actually the idea of a Euler function. So simply as it is, exponent 2 theta j to theta power with the exponent theta bracket 2 square. So that will be the same. So be careful about this. And factorization. So this is actually the common, I guess. B tolak B kuasa 2 tolak 4AC is actually, yeah, the things that been covered before. I guess this is as a basic thing in our mind, hopefully. Long division, we have this. So be careful about the remainder. So this is the Baki one, and this is the answer. So yeah, so this one, how we gonna get the x squared plus quadratic division and so on and so forth. Say that we have this and this. So what will be our answer and remainder? Okay. And irrational function, meaning this function, like say that we have x and the periodical n function as n0, n1, 2, 3, 4, and so on by this n. Okay. And this one is a product, so be careful about this. This one, need to be sure about an equal 1 over 1 minus a and so on. So this one, you need to be careful about this. So later on, we talk about in the chapter 2 soon. And this one too, yeah. So this is actually pre-understood things before we go through to this chapter standard. It's not standard, chapter 2 soon. Okay. So that would be the idea of chapter 1.
Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.